on the time. Let me see you enable the video. But let's
Alright.
but it's the sign that you made mistake. The numbers and letters are correct. You made mistake. I told you the order. The plus minus plus minus plus minus plus minus. That's just where you made mistake.
Okay.
M5, this will be minus 4, M4 prime, M1 prime. Plus what? Plus 6. Huh? Hello, Shay.
Hello?
M15. This 10. M, 10 M what?
No.
M1 prime square. Are you with me?
Yes.
Of 10. This is instead of writing plus. Instead of writing plus minus plus, you're going to put minus 10 M what? M2. Are you there?
Yes.
1 prime 3. Hmm? Then I have plus minus plus minus plus 5 minus 1 is what? Plus 4 and 1 prime raised to power 5. That is what I should have. Is that what you have in your book?
Let me see.
What was correct, but the signs are wrong. You made mistake at this second to the last point. This second to the last.
I don't know. Where's the book? Where's the TV? What do you have? Life is serious.
You said what?
What do
Yeah.
Okay, I'm trying to figure it out. Where the thing is.
It's just a sign. The letters and the numbers are correct, but it's just a sign. And I told you that the order will move. It's plus, minus, plus, minus. Anything you will get. Once you have gotten plus, that's the first one. The next one will be,
Okay, then I've corrected it. Let me correct it.
it moves in that order. Plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, like that.
All right. Plus minus plus minus. Okay, I've corrected the sign then.
That is the concept. Can generate for 6 moments, 7 moments, 8 moments.
All right, no problem. Thank you.
Okay.
Okay.
But just know that this is the answer I'm going to have at the end of the
All right, thank you.
Now, please jot it down. So,
No, I've jotted it down. I've jotted it down.
quotations of moments for group data. Now, so far, so good. I've been able to tell you what the group data is. Then we can now remember for group data, moment is always what? We have mean derivation, and we have summation x minus x bar raised to power r over n. So I told you that this particular n1 is always zero for first moment, n2 summation s into x minus x bar us raised to power n is what this variance. This is for group data. Are you there?
Yes.
Second moment is the variance. First moment is what? Mean deviation. Are you with me?
Yes.
Then when your mean becomes zero, it is called moment about it is called moment about the origin. When mean becomes zero, it's a moment about the origin. Now, I can now for coding machine method, coding machine method, or coding method. Coding method, I have my what? MR prime to be what? Summation F of U prime over what? Over N. Are you with me?
Yes.
One is called arc moment for a group data. Arc moment for a group data. Where you, anytime the formula for you, U equals to what? X minus A over C. Can you remember?
Yes.
So that is it. So we'll be working with this. So you can write this one in another form. Remember, I also multiply by C. Just write C dot. I also multiply by C. I can write this one in another form. Are you there?
Yes.
By removing the summation and put what? Long bar like this. I'm going to put the long bar this way. 2 raised to power r, u raised to power r. Put the long bar, meaning what is what? Summation F over N. So we define this one also as the what? As the moment about the using the coding method. So I'm going to write other ones. You know, when we were studying mean, median, and mode, variance and standard deviation, we talked about using the Charlia's check and Shepard's correction to check if our variance and standard deviation is right. So we now define each of them as well using the Charlia's check. So we go back again and write Shepard's correction and Charlia's check in terms of what? In terms of moment. So all this formula, I will not be using it. We'll be using moment to what? To solve them. Are you with me?
Yes.
Summation F or summation something to solve it. So Charlia's check, we will remember Charlia's check. Can you see the board?
Yes.
Remember, Charlia's check, I have what? For the first one, I have summation F into U. Charlia's check. By the time you remove the summation, you have summation F of U, summation what? Summation F. So this one means what? Charlia's summation F means what? Means N. You can extend it to what? Summation F of U plus 1 raised to power 2. Now summation F into U plus 2U plus 1. So if you open that bracket and take the summation of that U squared plus 2 summation F of U plus summation F. Can you see what I'm writing?
Yes.
So this one will be summation F of U squared plus 2 summation F. Summation F means what? N. So you can go ahead and write for 3, write for 4, write for 5. Using your book, I'm on page 124, 124. I'm on page 124. So you can, the same thing, apply binomial expansion. Can generate for 3, can generate for 4, can generate for 5, and so on. So I'll write moment for Shepard's correction. This is the way we write it. Let me write the corrected variance. What did I call How do we represent variance in terms of moment? What symbol do we use? Moment in terms of variance. What symbol do we use? M what?
Shit.
M what?
M MD. Sorry.
In terms of variance. I'm going to write M1 to M3, M4, M5.
Oh, sorry. M1.
I want to write variance. I want to write in terms of moment. I'm going to write N7, N, I'm going to write M what? Still on the top. I'm going to write what? N2, N2. So Shepard's correct.
M2.
Correct. We only correct Shepard's correction. Corrected variance. Corrected variance. Corrected variance. Correct. N2. N2 for Shepard. Can you? This is the way it's being written. N2. We see what? Two. Can you remember?
Yes.
Now, I want to write N4. You need to memorize the formula. M4, Shepard correction. This one is what? Corrected. Remember, it's corrected variance. So, corrected variance. Correct M4. Because of M4, you need to memorize the formula. M4 minus 1 over 2, C raised to power, C raised to power 2, N2 plus what? 7 over 240. 7 over 240, C raised to power 4. So I told you what the Shepherd correction does, isn't it? At times, for variance, once your value is greater than, once your earning is greater than 30, you need to, statisticians use to multiply it by n minus 1. If it's variance, you multiply by n minus 1. For standard deviation, they multiply it by n over n minus 1. Good. So, but we can use the Shepherd correction to correct it as well. I think for M3, you don't need the Shepherd correction for M3 because M3 is already correct. Are you with me?
Yes.
M3, yes. According to statistician, M3 is already, whatever value you have for M3 is correct. So the only place that has some hiccups is what is N2 and N4. That's the formula for it. After generating the normal variance, you import to what N2, then you remove it what? You will just remove 1 over 12 C squared from it. That's just remove 1 over 12 C squared from it. Can I move on?
Yes.
I think that one is very helpful. So, moment in dimensionless form. There's something we call moment in dimensionless form. And we use this to generate the stillness and the what? And the kurtosis. Please, my time is not helpful. We have not started anything. The time is already not. So let me generate moment in dimensionless. I'm still on page. I'm on page 124. Page 124. So moment in. Can I rub off everything here?
Yes.
So moment in dimensionless from moment in dimensionless. So I'll prove that one for you later. Other ones I'll prove it for you later. Because the first thing I do is to give you the formula, apply, then we'll move on. The moment in dimensionless form is given by E subscript R equals to what? N subscript R over S raised to the power R. So R can be any number. So if, for example, you have your, hello, are you there?
Yes.
You can't see what I'm writing.
No, I can see it too.
N equal to N subscript R. Now, this S alone is called what? Ordinary S in statistics is called what? Some textbooks will use sigma. Ordinary S in statistics means what? Variance of standard deviation. Ordinary S in statistics means what?
Variance.
No, ordinary S means what? Standard.
Standard deviation.
Now, variance is what? How do you represent variance?
S squared.
So this one is standard deviation. I know square root of both variance. And the standard deviation is what? Square root of variance, isn't it?
Yes.
What is my variance in terms of moment? What letter?
Variance in terms of moments.
One M to M,
D
which one? It's still on the board.
is M.
It's M2, variance, M2. Variance is always M2. Then this R, raised to power R. Get that?
Yes.
So I can move on, right? So let me put notes. Notes. S equals to standard so that you remember. I've been repeating it for S squared equals to what? That equals to N. Can I go on?
Yes.
If my M1 equals 0, if you have M1, according to this formula, you have R equals to 1. If you have R equals to 1, when R equals to 1, I'm going to have 1 like this, M1 over what? Isn't it?
Yes.
So what is M1? What's the value of M1? If you followed me from the beginning, M1, what do we call M1 first? Say it in words, M1. What does M1 mean? Want to check your note back?
Yes, let me check my notes.
That's why I explained it. I listed it.
Sorry, M1 means first moment. Sorry, first moment.
First moment is what? What's the value for the first moment?
The first moment, the value for the first moment is what's it called? Um,
What do we call the first moment? What another name we call the first moment?
what's first moment about the mean?
I didn't say about anything. No. When you say about the mean, that means you are putting prime there. I said first moment. What do we call it?
First moment, what do we call it?
Or M1. I defined it for you. M1. Another name for M1 is what? Mean deviation.
Mean deviation. Sorry, mean deviation. Mean deviation.
Mean deviation is called what's the value? What's the value of mean deviation in moment? Mean deviation is what?
0.
So mean deviation is zero over x1. That means a1 is
Yes.
one. That means a1 is what? Zero. Right.
Yes.
Move on and define a2. A2 is what? M2 over x raised to power 2. Are you there?
Yes, I'm there.
When r equals to 2, this will be m2 over x raised to power 2. So it's like saying, look at this, it's like saying, what do we call M2? What's another name for M2? I've been repeating it over and over again. What's M2?
M2 is the second moment or
Moment or what?
variance.
That means what is x raised to power 2? What another thing we call it?
What's x raised to power 2? S raised to power 2 is s raised to power 2 not also variance?
I don't want to confirm, so that we are following. So let me see the dot. It's variance, right?
Yeah, so that would just equal to 1.
It's equals to 1. That is
Yes.
H equals to 1. So I think the textbook jumped those calculations. That's why I'm taking time to explain it. So A1 is 0, A2 is 1. So note it before I
A1 is 0, A2 is 1.
proven that for A1 is 0. I've proven why is 0 for you. Because first moment is 0. A2 equals to 1.
Mm-hmm. Yeah.
Can I move on?
Yes, you can move on.
Right. So that's about moment in dimensionless form. Hello, are we together?
Yes, yes, yes. We're together.
So let's move to skewness.
All right.
When we talk about skewness, we are talking about symmetry. You've heard the word symmetry before, right?
Yes.
I'll still go back and prove the M1 into N2 after working now. Maybe I can prove it for you. So skewness has to, when you have X and Y, then some skewness can be this way. Some can be lifted more, than the other. Some, you have it more like this, but it's tilted more. So when you have this is what we mean by skewness in diagram form. So I say that this one is perfectly skewed. This one is like skewed to the left. This one is like skewed to the right. Are you seeing it?
Yes.
It has to do with what degree of what asymmetry or departure from symmetry. What we mean by an origin. So when we have degree of departure from symmetry from the origin, that's what they're trying to explain. That's what we call skewness. From the degree of asymmetry or departure from symmetry of a distribution, then we define it as what? As skewness. Now, this particular one, you can't say it's either positively skewed or negatively skewed. You will say it's perfectly skewed because it's skewed to the left and it's also skewed to the right. They are what? They are equally skewed. So if you look at this one, it's skewed to the left. You will say it's negatively skewed. While the one to the right, you say it's positively what? Positively skewed. Are you with me?
Yes.
When you look at another case is what they call another case is what they call thickness. Thickness. It's not touching the line. Another thing is what they call peakness. You can see that this particular graph peaks up compared to the one that is down. This one peaks up. Are you there?
Yes.
So we define kurtosis as degree of peakness of a distribution. Thickness of a what? Distribution. So we can have many distribution to the platycortic or leptocortic. Are you with me?
Yes.
All these ones, there are different types of kurtosis. So what we just want to define here is kurtosis, the degree of thickness. Is it clear?
Yes.
I want to give some formulas on skewness. The next class we will take, each of them will take exercises on it. Then we hand skewness, kurtosis, and rest of them. They will move to probability. So I think we are moving fine. What is going
All
on?
right.
Do you need to jot this down or I should rub it off?
Um,
Positively is skewed, well skewed, negatively skewed, positively skewed, and this kurtosis.
no, I'm okay. I can. You can. We can continue next class.
Continue next class. I want to still write some formulas for you. I don't want to discuss this next class.
All right, then no problem. We can continue anyway.
Just give me 2 minutes. So skewness is given by what? Mean over what? Over standard deviation. So we write mean like this. Then we write minus mode. What's the symbol for standard deviation? What's the symbol for standard deviation?
The formula for standard deviation is what? X minus X bar.
Symbol, I'm not going to give me.
Sorry, S. The
So
symbol is S.
Remember, in the last class, I give you some formula relating to kind of better class. Right. So you now plug this one back. Okay. Given x equals to what? 3 mean minus, yeah. It's under the relationship between mean and mode in your book. Are you there?
Yes.
So we can also, there are other equations that relate to skewness, which we call quartile coefficient of skewness. Quartile coefficient of skewness. And quartile coefficient of skewness is given by what? Q3 minus 2Q1, 2Q2 plus Q1 over what? Q3 minus Q1. Q3 minus 2Q2 plus what? Plus Q1 over Q3 minus Q1. Another one we also define. Another one we also is in your book. I'm on page 125. Are you there?
Yes.
Percentile. Just like you have in your normal measures of central tendency. You also have all these ones there. So percentiles is defined as well P90 minus 2P10, 2P60 rather, plus 2P10 over 90 minus what? P10. All these formulas are very vital in solving percent. So all I will do in the next class is to solve questions for you relating to this and then end the class. Any question on this?
No.
I wish I should do the other assignments yeah?
Pardon?
The other assignments I have not finished. The other assignments I have not. When did you finish?
The other assignments.
Okay, the one you said you don't understand. I gave you 2 assignments.
Shit. What was the question for the second one again now?
I told you to jot it down. Look at your book now. Didn't you jot it down? Didn't you jot it down? Did you jot it down?
I must have jotted down the wrong one. That's the issue. Because now I was like, I don't. This is the assignment. Okay, yeah, therefore did not jot this shit down.
The one I gave you is on X bar plus or minus mean deviation. I remember.
No, I remember it's just the exact question. That's the one because I think I missed it.
Right.
I'm sorry. Well, let me go and check the chapter. Okay, most. Jesus Christ.
118.
You said
118 question 4.42. Page 118 question 4.42. That was the question.
okay, question 4.42. Okay, now that I have it, I'll do it and send to you before tomorrow's class.
So do have a wonderful day.
All right, thank you.